This video I will explain how to use Codesys, a Raspberry Pi, and Weidmuller's Remote I/O product to create a project. So first thing that you will need to do is go to the Codesys website, download the Codesys control for Raspberry Pi, and then we can get started, and I'll show you the steps. So we'll create a new project, and you see the device I have here says Codesys control for Raspberry Pi. So I'm going to go ahead and say OK to that, and I'll tell you how I got there. So the download of the Codesys control for Raspberry Pi is a package. So once you download that, you click install, and then you browse to where you've saved your Codesys control for Raspberry Pi. And make note that the version here I have, and the latest version online on the Codesys website, is 3.5.9.20. So we'll need to make a change in the project later on for that. So a couple other things that we will want to address also. So this is the Weidmuller cloud-based service. You can see I've got a couple locations here, but what I wanted to show was the Ethernet IP, the Remote Ethernet IP system that we're going to be working with. This is in a different location than I am. So there may be a little bit of latency just browsing, but this is the web interface for that remote system. Now, this isn't something that you must configure. Once you install the USB driver, you can connect to this with at the USB service port here. But you can also connect to the Ethernet ports here as well and access this web server if you're using BootP or DHCP, and that can also be changed. So this system here, just what I have is digital inputs, relay outputs, standard outputs, analogs, counter modules, and also some IP67 modules here. But what's important here is the information we're going to need for Ethernet IP. So just click on the fieldbus coupler, and then this is where I would go in to assign an IP address. You can see that I've done that here. I've set it static, assigned it 212, and then this is the IP address of the USB service port. So once that USB driver is installed, you don't need to change any IP addresses or worry with DHCP. You can just plug in your USB cable, which is a standard USB-A to USB micro cable, and then you can access it at this IP address. So the important part here for Ethernet IP is you need to know the input and output assembly lengths. So conveniently, what Weidmuller does here inside the coupler, so you build your system however many I/O modules you need, and then it calculates the number of input and output bytes for you. So assembly 101 and 102 is what we'll be using today. That's 34 bytes of inputs and 16 bytes of outputs. 103 and 104 are also input and output, but those are that's bringing in the module diagnostics along with it. And then you can see the configuration assembly. It gives you that as well. That is 75. So the module configuration is held there. So that's what we need: 34, 16, and then we should be good to go. So we'll come back over here to Codesys. And we'll start configuring this project. So we're going to add a device. So we're going to add an Ethernet adapter up here. And you can see we've got this. Grab the Ethernet adapter, add device, and then select the Ethernet adapter, and then we can add the Ethernet IP scanner and say add device. And then from the Ethernet IP scanner, we can add the Remote fieldbus coupler Ethernet IP. So I have this here because I went to the Remote product page on Weidmuller's website and downloaded the EDS file. So then you'll have that here as well. A little bit of a shortcut. It actually pre-fills out some of the information for you there, and just saves you a couple steps. So now we can close this, and I want to address one other thing. So I mentioned earlier, make a note of the version. So what we need to do here is update this Ethernet IP scanner. So by default it comes in at the 35930, and we want to put that to 35920. It will default to the most recent, but we need to make everything match. So and this is because of the Codesys control for Raspberry Pi, what version it is, the latest version of that. So just select the right one, click Update Device, and then we're okay to go. So double-clicking on Ethernet, on the U-remote Ethernet IP fieldbus coupler, we just put our IP address in here, and then we can work on the connection. So if you chose to do the generic Ethernet IP device rather than using the EDS file for the fieldbus coupler, this will be empty. So you'll have to add the connection and then configure it manually. But this one's already in here. So what we're going to do, so here is the output bytes, and we had 16 output. We had 34 input bytes. And we'll change this connection type to multicast. And again, I'm going to change the requested packet interface here. It doesn't need to be 10 milliseconds. It's not a problem. I just don't need it to run that fast. So, and then Ethernet IP scanner. You can see here. See, now we have 35920, and then on Ethernet IP 35920. So we match there also. And now that we are on the same subnet as the Raspberry Pi, we've got this configured. The other thing we need to do is make sure the Raspberry Pi is on the right version itself. So we're going to put this 3.5.9.20 package on the Raspberry Pi. So we can put in the default username and password, username Pi, password Raspberry. I'm going to hit scan here, and we'll find the now what we're going to do is update the Raspberry Pi. So on the Tools menu, select Update Raspberry Pi, select the 35920, and go ahead and plug the password in. Default password is Raspberry, and I've already assigned my IP address to .2. There you see it's selected. Say OK, OK, and then it's going to connect to the Raspberry Pi and then actually update the runtime to match our system. Okay, now that update's done, go ahead and click the build. We've got 0 errors, 0 warnings, and now we're going to load and configure this active path. So then once we've finished updating, we're going to go to double click on device, open the communication settings, and we're going to set the IP address to the Raspberry Pi. Click enter, and now we can download. Okay, and then we'll put in run mode. Okay, so now we will click login, so download the program, and then once that's downloaded, you can see that we have a connection to our U-remote fieldbus coupler. So we'll just go in right here. Oops. So then we'll go to the fieldbus coupler, and we can see that we don't have any any bus faults of any sort. So just a good way to show some communication. We'll put this in force mode, and we'll go ahead and turn on some digital inputs, and then we can go back to Codesys, look at our I/O mapping. So of course the first, okay, so right now we can see that there's actually nothing showing, so this is expected. I've omitted a step. So we'll go back to the device, PLC settings, and this always update variables. I've set that to enabled. This will allow you to see any variables, whether or not they're in your program right now. So go ahead and do another download. Go back into run mode. And the first bytes of input and output data are reserved for the first words. First 2 bytes of each of input and output are reserved for the coupler, status word and control word. And you can see here that the first 4 inputs are turned on. We'll go ahead and turn a couple more on and jump back over just to see. So this is a unique tool for Weidmuller on our fieldbus coupler. Being able to do this from the web server. It's very useful for pinpointing actual I/O points when using Ethernet IP or Modbus TCP. if you have any questions, please feel free to post a comment, and I will get back to you as soon as possible. Thank you.